you clear
Yes,
to?
yes,
Okay.
this is clear.
Okay, let's start. Bismillah Rahman Rahim. Today webinar topic is career development and safety for electrical engineers. Basically, what thinking right now is that safety is for safety professionals only, but there is increasing focus on incident and accidents happening in general industries and in construction industry, which is related to electrical hazards. And for me, that need to be addressed can be addressed greatly by electrical engineers. So electrical engineers should step into this safety field. They should acquire basic understanding of electrical hazards post to their work, so that they may create good work, safe work condition, and apply the latest best practice available in the domain of electrical safety. So there is the topic for today is transform your career. We all are electrical engineers, maybe working or maybe safety professionals, and how we can transform our career to a specific specialized field. We might be having a degree in electrical engineers, or we are CSP certified, we are ASP certified, we have DBOSH credential with us, but there is a specific specialization in this field, and we will going to talk about this specific certification. And it is not only related to the electrical engineers, but it is greatly related to safety professional as well. So the main thing is working in electrical in industry comes with big responsibility. Why? We will going to discuss throughout this webinar, and it will be a very interactive webinar as we move on for next 50 to 55 minutes, and we will be taking some question and answers in the middle and as well as in the end. So about me, my name is Sayed Wasim Naseem. I am basically an electrical safety and asset management professional, and have interest in energy and environmental management as well. Right now, I'm holding the highest certification in the field of electrical safety, which is given by NFPA, United States, which is Certified Electrical Safety Compliance Professional. And if you Google this certification, and if you go into the LinkedIn and find these people who are CSCB certified, so you will find around 300 or 400 CSCB certified people all over the globe, including 2 or 3 in Saudi Arabia only, and in MENA region, very less number of CSCP certified are available. I'm CAMA certified asset management assessor from WPAI in Australia, certified practitioner in asset management from Asset Management Council Australia, and holding lead auditor in energy management, quality management, and environmental management from IRCA, UK. One of the most frequently asked questions when I conduct brainstorming session with my colleagues, my friends, why we should go for certification, why it's necessary to have certification with our name. We are engineers, we have bachelor's degree, we have been doing work for 10 years in one field, 15 years in world field. Why we need certification? So the answer to them, to this question, is now the organizations are demanding evidence of competency based on international best practices. So if you have certification under your name, so you will be equally qualified to work in Middle East. You will be able to demonstrate the same level of expertise, same level. You will be using same terminologies, and you will be applying same concepts in Middle East, in North America, in South America, or in Australasia, or in Asia. So what does this have impact on your profile? This is some certification which I have tagged under my name. So it looks, first it looks good on your tag, on your badge, and it shows that you have competency, you have required knowledge, skills to implement that system, and you can add value to the organization, and bring in improvement, which every organization looks for from his employee. For example, Bill Cater, he's my teacher of CMRP. He is Certified Maintenance and Reliability Professional, CRL, Certified Reliability Leader, Certified Asset Management Professional, and Reliability Engineer. He's a trainer and consultant. And other example which I have taken from LinkedIn, Mr. Bander, ECMRP, CRE, CRL. So these are the certification which speaks itself for the person who will going to have in this competitive market. If you will be penetrating in market, you should have these certification now, which is becoming a norm, which is becoming compulsory for you to have under your belt. So specifically now we will talk about why electrical safety program is important for industries. We have uh, OSHA, we have ISO 45 implemented. We are following OSHA standards and other safety procedures as per the company policies and international best practice. So why we should specifically have an electrical safety program under our occupational health and safety program? Why there should be a dedicated electrical safety program? To give you answer, this is a safety triangle given by NFPA. If we look at this safety triangle, on the left is the safety triangle for general hazard, which we come across in our construction and industrial uh, work environment. So if you have 300 recordable injuries, the conversion rate to one fatality is 300 into 1. But for the electrical safety, the hazard is because it's like a silent killer. You cannot see electrical current charges. You should have special techniques, and you should have a good sense to detect where is the hazard available. So if you have 10 recordable injuries in your facility, the chances to convert that is fatality is to 1. So on the left, for the general hazard, as per NFPA record, it's 300 is to 1, and for electrical hazard, it's 10 is to 1. So if anyone has some point which they want to make here about electrical hazards or electrical incident or accidents which has happened into their industry, uh, we are happy to listen that from you. Anyone want to share some
Yes, sir.
incident which happened
Just
to him or to his any colleague?
yes, sir. Just recently, we have one accident in our electrical panel. There is a one lizard coming into our panel, and the panel is suddenly shut down whole plant, and total blackout in our plant for 2 or 3 hours.
Right. I will going to discuss in coming slides that electrical safety is not only working safely. It comprises of all other dimensions, other two dimensions to make your system completely safe. The example which you gave is linked to the unplanned outage caused by non-compliance with the design side. So there was a hole left from where the insect was able to enter into the electrical panel, and it caused unplanned shutdown, the loss of production, the value lost, the production loss, and a bad image for the company. If we talk about the injuries rate in United States, this is from 2012 to 2016, issued by NFPA. The next will be issued after 5 years in between 2000 end of 2020. So in United States only, there are 9,760 electrical engineers at work have been reported and 739 electrical fatalities at work. If you go to the OSHA top 10 citation, you will find electrical as in the first 5, and there are 2 citations last year. Now due to the application of best practices, only 1 citation is remaining in top 5. So I will advise you to visit OSHA citations website, and you will find in top 10 the electrical hazard citation is in top 10. Mostly people think that electrical hazard is only related to electrical shock. If you are working and you can get shock, and there is only one hazard related with this. Since 97 and 98 onwards, the industry has identified another type of hazard related to the workers who are working with electrical equipments or who are surrounded or by the electrical equipments, and that is an arc flash and arc glass. So two other categories have been added in the electrical hazard, which is electrical shock, electrical arc flash, and arc glass. So this is a result. This is a picture of a person who had an arc flash incident while he was installing a meter box outside a switchgear. This is the job which he has done more than dozen times, but there was maybe some non-compliance with the requirements, or maybe he was tired at that time, he was not focused, and that only moment created the arc flash event, and his body was burned to more than 30 to 40%. And this is a picture which has been taken after 5 days. I have pictures of the initial 1 day and 2 day with me, and it was very scary, so I did not put it here. Apart from arc flash and arc glass, what are the impact on your facility? So if you try to work on the life system, so it could cause an arc flash and arc glass, and it could cause a complete shutdown for the unknown duration. So that means if you are not following the electrical safety best practices, and if you are not taking a proper shutdown of the system, so you can move from a scheduled known duration shutdown to the unknown duration shutdown. So what will be the result of this? The production is lost, long shutdowns, unplanned shutdown. You have high replacement cost. The image of the company will be in danger. They will not going to meet the targets of production. Something related to the asset management. If something goes wrong, what happens exactly in electrical safety when we talk about specifically to this one? There an arc flash event occurs, and it was not planned. Right now we are only discussing the things which has happened as a result of bad working practices. We are not defining right now the design constraint or the maintenance error. I will, in the next coming slide, I will going to show you a big picture, what makes an electrical system safe, working and work conditions safe. So these are due.
I'm sorry. What we are saying here, okay, most of the errors in the electric safety is due to human errors, mistakes, the fatalities, and not the design. The design, if we come to the design, maybe 5 to 10% bad design. The rest is human errors. Right or wrong?
Right now, I'm not generalizing this one. Yeah, in the coming slide, I will show. Yeah, I will show.
Go ahead.
Okay. I will come back to the previous slide. Just want to give the answer to him. This is electrical safety wheel. If you want to have a good electrical safe system, you have to implement three standards at a time: NFPA 70E, NFPA 70B, and NFPA 70 NEC. If we talk about the NEC, which is NFPA 70, this is related to the design. This is related to the electric code. how you will going to design, how will you going to commission, how you will going to install that equipment safely, so that in the normal operating condition, it should not create electrical hazard to the workers who will going to interact with the equipment, or who will be just passing by that equipment. Let's suppose if you have a switchboard installed, main circuit breaker installed in your house. So it should be installed and designed as per the requirement of NEC, National Electric Code. So in the normal condition, it should not spark. It should not have a arc flash. It should not have an arc flash. If touching the enclosure, it should not give you an electric shock. So this is covered in NEC, National Electric Code. NFPA 70B, which is related to the maintenance of electrical equipment. It says that a periodic maintenance or condition-based maintenance or risk-based maintenance should be carried on or your electrical equipment to identify any impending failure by using thermography or by using USD, ultra discharge, so that you may find that there is some problem arising, so that you may take either preventive maintenance or emergency maintenance or condition-based maintenance to keep the integrity and the safety of equipment. When we talk about the NFPA 70E, which is standard for electrical safety in the workplace, it says that if the equipment is designed safely, installed safely, and it has been maintained safely over its life cycle, complete life cycle. So in this case, now only the focus comes how you will going to minimize the human error, which you are talking about. So NFPA 70 is basically the standard which deals with electrical safety in the workplace. It talks about the principles. It talks about how you will going to interact with the equipment. It's for basically the person who is deliberately going to interact with the equipment. How you will going to take the shutdowns. How you will going to create an electrical safe work condition. What are the approach boundaries? So I hope I have answered your question.
Yeah, yes, you answered it. Like the 70E, the way you're saying, that's what my question on that one.
Yep.
Because some people buy extensions from the market commercially and they hook it and they overload it without knowing what they are doing.
Overloaded
Especially at the workplace.
Overloaded come under NFPA 70E because the equipment is designed. Equipment is designed and installed for some specific load condition. Now, how you are overloading, how you are interacting with equipment, if you are going above its rating, that comes NFPA 70, electrical safety at workplace. Yes. The pictures I'm showing, it might due to the reason of non-proper installation. It might be due to the reason of non-standard design, maybe equipment problem. It might this might have gone wrong due to the maintenance is not done properly, or it might due to the reason that a person tried to fix that fuse in the box in the life, and he did not apply the safe work practices, and he was not competent to do that. So NFPA 70 covers that part, the human interaction.
Or could
part.
Be the insulation, like water came through.
That will be given by the answer by NFPA 70 NEC. Why the design has that flow, that ingress was there. Why the water came inside the enclosure. So these type of answers will be given by NFPA 70 NEC, National Electric Code. And the maintenance answer will be given by NFPA 70B. How frequently you should maintain your equipment. And NFPA 70E will deal how you have to deal with that equipment, how you have to keep yourself safe from electric shock, arc flash, and arc blast when you are interacting with that equipment. So the main purpose of NFPA 70, don't take shortcuts, don't take electrical safety for granted, because since childhood we are playing with electrical currents. We have been putting fingers in our sockets and we are switching on and off. So we take electricity as granted that it will not have an impact. The study shows that the most of the incidents occur in low voltage compared to the high voltage, like less than 1,000 volts, which is considered as LV. Most of the incidents occurs in that phase, because the technician, because the engineers take it easily that we have been interacting since our childhood, so it's less risky. The hazard is low as compared to if you are interacting with that system on 4.4 kV, 11 kV, 33 kV, or 132 kV. You know that there is some hazard. You take extra uh, precaution in that one. Today, we will focus on NFPA 70, electrical safety at workplace. So there is one on the left. This is a standard NFPA 70, electrical safety in workplace, and on the right, it's a handbook which explains the standard. The standard itself is of around 50 pages with some annexures and other thing which makes it around this book on the left 90 or 100 pages. And NFPA 70E handbook, which explains the requirements of the standard, it's more than 300 pages. So what's the purpose of NFPA 70E? The main purpose of the NFPA 70 to provide a workplace free from electrical hazards. And the second option is to do the work while the equipment is de-energized. Conduct the shock risk assessment, arc risk assessment, and take the appropriate measure to safeguard yourself and your team from electrical hazard. If you go to the NFPA 70, how this standard is made, it's comprised of 3 chapters in annexure. Chapter number 1 is related to the safety related work practices. Chapter 2, safety related maintenance requirement, which gives a touch of NFPA 70B, which is a maintenance requirement, and it refers reader to adopt the best practices given in NFPA 70B. Third chapter is related to the safety requirements for the special equipment, like if you are dealing with laser, if you are dealing with electrolytic cells, telecommunication. There are also electrical hazards available. So it deals with special equipment. And the last is the informative annexures, which contains explanation to some of the concept given in chapter number 1, 2, and 3. So here's some activity just in your mind. Match the column. What is shock hazard? What is arc flash hazard? What is arc blast hazard? And thermal burn. In 30 seconds, anyone can give the answer, and I will going to show the correct sequence. Okay, anyone with the answer, or what is a shock hazard?
So that is number C, a source of possible injury associated with current through the body caused by contact and that one.
Right.
Approach to electrical conductor or circuit parts.
Great. What is the arc flash hazard?
This is the number 1.
Sir, number 1.
Perfect. And arc blast?
Number D.
Oh,
No, the second one.
Number 2.
Number 2.
Is number 2, and the thermal
That's
burn
lost.
is last one. So
Last.
so what basically a shock hazard? We are being taught about the and we have been made aware of shock hazard since we are working in electrical field or being safety professional. We tell the technician and engineer that there is a shock hazard. Wear gloves, and have safety shoes, go and work. But while working, if you intentionally or unintentionally short two phases, or if there is some drop of tool, there is short circuit happens, and that short circuit between circuits converts into an arc flash event. The temperature of that arc flash event is 35,000 degree Fahrenheit, which is approximately the temperature of sun. In some arc flash event, the temperature can reach more than 35,000 degrees Fahrenheit. It can cause you severe burn injuries from 3rd degree to 4th degree burn injuries. Followed by that, in arc flash event, there is an arc blast simultaneously occurred, which causes the air to expand with pressure and melt the metals which come in its ways, like conductors, enclosures, and that conductor and enclosure become in small dots. It's like a bullet. It becomes like a red hot bullet, and their speed goes up till 700 miles per hour, which is a speed of supersonic something, which can penetrate in the body and can cause a deep burn in your body. Non-explosive event occurs at the same time, which has a dB of more than 140 dB, which can easily have a high impact on your ears, and it can make you deaf. The explosion have so much high intensity radiation, and it can cause a complete blindness. So up till now, in many industries in which I have worked up till now, in Pakistan, in Saudi Arabia, in UAE, and I've been discussing this topic with others. The people there, the safety professionals, the electrical engineers, mostly consider electrical shock as the only source of hazard present in their work. Most of them, they are not considered this arc flash and arc blast hazard, and so that they don't conduct the risk assessment of this both hazards present in their facility. If we talk about the arc, if we talk about the shock, so what is the minimum amount of current required to create serious injury or something related? For it differs from body to body, from male and female gender, from kids to elder age. The minimum is 6 milliamperes. If you have a 6 milliampere and you are exposed to that shock of 6 milliampere, you will not be able to let go from that energized conductor. You will hold that conductor tight and more tight, and the time will going to increase, and that 6 milliampere will continue to flow through your body. Unable to let go means that your muscles are so much strained that you are not able to release that conductor or that energized part from your head. And 70 milliamperes could cause you a serious burn. As I told you earlier, that it varies from person to person. The 6 milliampere is the minimum limit given in that case. 15 to 23 milliamperes for other part of group, it's is given for the people. 0.1 amps, it can cause you ventilate problem in your heart, how your heart behaves. Yani there is a rhythmic pumping of your heart. It can cause effect on that pumping. 0.5 milliamperes cause your heart and muscle activity ceases completely, and 1.5 amperes cause tissue and organs burn. The 4 milliampere is that ampere which can cause a complete death of a person in many cases. So if you are safety professional or electrical engineer, you remember what is the current setting of your GFCI, ground fault circuit interrupter. Can anyone answer me?
I have a question over there, if you please allow
30
me.
milliamps.
The milliamps has been categorized So what will be the voltage level? Can you please describe the voltage level on this? They can be fatal for our body.
What if you consider the voltage and current relation, voltage is basically a pressure which is driving a current to pass. Okay, so the higher the voltage, the more current will pass quickly. Okay, the impact on the body is with the amps. It's not with the voltage. Yeah, voltage does have the impact of passing that current quickly through your body and cause you a fatality or burn injury. But it is the ampere which is the main cause. So this ampere could be at the 220 volts, 400 volts, 1000 volts, or 11 kV, or 13 kV, and you may go up. Or it could be a connection of your battery cells. If you remember, if you touch the cell with your tongue, it causes a sensation, a pencil cell which you use in your remote. So if you continue to do that, a time will come then there will be a loss of sensation. So it's independent here. Mostly the effect is the ampere which is causing this problem. Voltage is a driving force which causes things to happen more quickly. I hope you got the answer of this.
Yeah, thank you. Because I have asked this question, many people, when we use to work on the circuit boards, PCB boards, because it's considered in a very low voltages, just like in the millivolts. So actually my question was that in the millivoltage level, does this ampere rating affect on body for the damages?
Yeah, because it's dependent on the current. It's dependent upon the current, irrelevant of the voltage. Voltage is a driving force which is causing that current to flow.
Sure.
So,
thank you.
So my question was, what is the setting of GFCI? If anyone can answer.
30 milliamps.
I think 3 milliamp.
Okay, you are close. It's 5 milliamps. 30 milliamps is for the out circuit breakers in some cases. But when you are working in a wet environment or when you are working with the hand tools, it's 5 milliamperes. So why it is 5 milliampere? If you divide your body resistance, which is in normal condition is 1000 amp divided by the voltage, 200 or 400, it comes around 0.00 milliampere. So in that case, it's okay. But if you have a wet body, your body resistance drop to 1000, and if you divide that 1000 with 220, it comes around 5 to 6 milliampere. So that portion in which there is a unable to let go scenario comes. So that's why the GFCI is set for 5 milliampere to provide you additional safety if your hands are wet, if your body is wet, if your GFCI is basically installed in kitchens and washrooms and for the outdoor activity. So in case if you are wet and there is some leakage of 5 milliamp, just above 5 milliampere, so GFCI will going to trip and isolate the circuit and will make you safe. So can anybody have the answer that what is the minimum voltage which is allowed as per NFPA 70E to work live? After that voltage, you have to establish an electrically safe work condition, which means shut it out. Any guess? What's the minimum voltage?
The minimum voltage. 12.
Okay, someone else?
50.
Yeah, it's 50. If you are working on 50 volts and above, you have to shut it off. You have to take the shutdown. You have to ask your electrician and engineers to work in an off position, in a shutdown position. You are not allowed to work in an energized condition. Unless you have filled an energized electrical work permit, in that electrical work permit, you will going to conduct a risk assessment. And in electrical safety, there are two types of risk assessment: a shock risk assessment and arc flash risk assessment. And in the shock risk assessment, it is defined what's the voltage level there and what the PPs you will going to wear for that working in that live condition. And if it is determined that there is an arc flash chances, so you have to wear the PPs according to that incident energy level. The incident energy is measured in cals per centimeter square, and it is from 0 to 40 cals per centimeter square or even higher. The personal protective equipment for arc flash uh, PP is up till available till 40 cals per centimeter square. If the incident energy is more than that, you have to work in shutdown format. You have to create an electrically safe work condition. The energized work is not allowed. We will going to discuss this in detail because these are very in-depth topics. Uh, in order to have a live work for the voltage level, if you're working less than 50 volts, you are permitted to work. But if you are working on greater than 50 volt as per NFPA 70E, there you have to create an electrically safe work condition. So there are two types of boundaries with electrical hazards, and these are the two tables given: 130.4 and G and B, which is one is for the AC current and one is for the DC. If you have an energized body here, let's suppose circuit breaker in which you are working, so there are two boundaries available: limited approach boundary and the restricted approach boundary. This is determined when you are working on the live system and you have an electrical work permit and you are filling that electrical work permit. Why you will going to work on the live? First of all, the main objective which I discussed with you is to shut it off, have a shutdown. But if you want to work on live, then you have to fill an energized electrical work permit. What are the reason to work on live? If that electrical supply is giving supply to some hospitals, to some emergency equipment, to some area which is very critical for the industries like ventilation system, it cannot be shut down. So this justification will be written in your energized electrical work permit. And in that work permit, you will going to fill this two boundaries: limited approach boundary and the restricted approach boundary. And these are determined from this table, 130.4 G and A from the NFPA. How? It's a detailed topic, and we will going to discuss when we will going to focus on this topic in future. So a knowledge check: which of the following do you think are the minimum requirement for establishing an electrically safe work condition? I have just discussed these points. In this 4 points, 2 are correct. Can anyone?
3 and 4.
3 is okay.
2 and 3.
3 is okay.
Second and third.
It's first and third. It's first and third. What is this limited approach boundary? If I go back to this slide, limited approach boundary is that boundary from your energized equipment, which can be in millimeter, meter, at which a shock hazard exists. And the restricted approach boundary is that boundary in which there is an increased likelihood of electrical shock. So what's the difference between these two? Limited approach boundary is basically made for people to distinguish between a qualified person and unqualified person. A non-qualified person will not be allowed to enter this limited approach boundary. It is dependent upon voltage. The higher the voltage, the greater will be the limited approach boundary, and you have to keep your unqualified person people away from this one. Restricted approach boundary is that boundary in which a qualified person with personal protective equipment will be working on the system while the system is energized, with taking all the safety measures, practicing electrical safe work practices, and a qualified person can only do. You know that electrical shock does not occur only when you touch a live conductor or something. There is a chances of arcing over to like there is a space of air in between which can become energized and conduct, and it can cause you electric shock. So this is a minimum distance. Yeah,
Can we call it as ionization of the air?
that is the reason which can cause you an electrical shock if you are not even touching. It's again based on the voltage level. The higher the voltage level, the greater will be this restricted approach boundary. Just like a candle, when you bring the candle close to your fingers, it does not necessarily have to touch your finger to cause you burn. When you come in some proximity, it causes you burn. Just like in with the dealing with electricity, when you come in so much close proximity, if you are not touching, there is a chances of electric shock by jumping over of the electrons. So for a electrically safe work condition, if you are working in the limited approach boundary and the voltage level is greater than 50 volts, you have to create an electrical safe work condition if you want to do work. Another activity, where does an arc flash hazard exist? For example, we are now talking about only NFPA 70E. We are not talking about NEC, which could have a design issue if the equipment is not properly installed and maintained. In NFPA 70E context, these 2 points are not covered. Yeah, arc flash hazard could exist if the equipment is not properly installed or maintained. But this is not a part of NFPA. This is part of NFPA 70 and the 70E. So I've excluded the 4th point. Now there are 3 remaining. So if anyone could can answer this one.
Number 2.
Number 2.
Number 2 is fine. Number 2 and number 3. Why not number 1? Under normal condition. Under normal condition is defined by NFPA 70, National Electric Code. In normal condition, when you are not interacting with the electrical equipment, so it is believed that arc flash hazard should not be there, because it is being controlled by the design of the equipment, by the installation procedure and other things, and the maintenance is proper. So number 1 is not the case. For the exposed conductor and circuits, yeah, when there is a conductor exposed circuits and you are interacting, or there is some lizard can come, there cat issues are very common. Cat is entering in the substation and causing an arc flash and arc flash. Or if you are interacting with the equipment, there is a chances of drop tool that could cause an arc flash even. During interaction, for example, racking in and racking out of a circuit breaker, if you are racking in, if you are working on this one, so that could also cause an arc flash hazard to occur. Okay. When an arc flash hazard exists, the arc flash boundary, there is another concept. There are 3 types of boundary in risk assessment. 2 related to the shock hazard and 1 is related to the arc flash hazard. With shock hazard, it was limited approach boundary and the restricted approach boundary, and when there is a chances of arc flash, there is a boundary known as arc flash boundary. So any wild guess about where should be the arc flash boundary to be? I will going to explain in 1 minute. Then you can have a wild guess about this one. It is that boundary. Beyond that, the chances to have a burn to an unqualified person is very low, because after that boundary, only a qualified person can enter into that substation, into that area of energized equipment to work on that equipment. And in case if an arc flash event occurs, then he will be having a very less chances of burn injury. This is just a hint to solve this activity.
That's number one. The distance at which a first degree burn is likely to occur.
Okay, first degree burn is that burn in which there is only a redness happens. Second degree burn is that in which there is a damage in the skin, but it is repairable. It comes back after some time. Third degree burn is unrepairable burn, in which your muscles and your tissues are badly damaged. And last one is the fatality. NFPA defined that this boundary should be made up to that point from the energized equipment where there is a chances of second degree burn. Meaning that if an energized equipment, there is an arc flash event occurs and the incident energy goes up till 10 meters and it causes a second degree burn at the 10 meter. So draw the boundary there and keep your unqualified person beyond that 10 meter and allow only your qualified person to enter beyond that 10 meter with all your PPs intact. So the second degree burn is that distance in which you will going to make the arc flash boundary. For example, if you have this energized equipment, energized conductor, this is an arc flash boundary at which a second degree burn can occur. And the second degree burn occurs at an incident energy of 1.2 cals per centimeter square. So this is a value which creates a second degree burn. So this is a standard of making an arc flash boundary. So now we will move towards some certification. We have 70 minutes left. What are the certification, highest level of certification available in this field up till now, from North America, South America, down to New Zealand, which is the one end of the world? There is only 3 certification, highest certification available right now currently in the world for the in domain of electrical safety, for electrical engineers as well as for other safety profession who can get this certification. One is the CSCP, another one is the CSW, and third one is CSCP. I will go fast with this one. Certified Electrical Safety Compliance Professional is the highest of its kind, and alhamdulillah, I'm one of them who has acquired this certification. It is basically for those who look for the electrical safety program. Electrical safety program, writing electrical safety program, auditing electrical safety program, developing the procedures, methods, training, development, auditing, all comes under electrical safety program. It could be the responsibility of electrical engineer or any other safety profession, and it is the highest certification of its kind, which is based on NFPA 70E. Second is the CSW, Certified Electrical Safety Worker Certification. It is for those persons who interact with electrical hazard or who are exposed to electrical hazard during their work, like electricians and other electrical professions who work hands-on work with the equipment. Third type of the certification is CSCT, Certified Electrical Safety Technicians. They are not basically the electrical engineers or technicians who are working directly on the electrical equipment, but they are working in a team of so they must be aware of the electrical hazards in which the other people are working, like their fellow technicians and engineers. So this could be a HVAC technician, solar, and some other person who are a part of the maintenance team. So they won't be working on the live system, but they will be a part of the complete shutdown of the work. Today I will talk about CSCP only requirements, and other we will going to talk later. CSCP, it's a long journey, and its eligibility criteria are a bit tough. First of all, you have to have a minimum 40 hours of electrical safety training, and that need to be covered in last 3 years. That trainings can be can be taken from variety of sources. If you can go to the US and take trainings from other sources which are accepted to NFPA. You get this 40 hours training, you will send this to NFPA, they will going to endorse your training, and they will accept that you have meet this prerequisite. This is for all candidates. If you are electrician, you have to fulfill your point number 1. You have to have the 40 hours of training, and you have to prove 4 years of working experience. This is a condition for electrician. If you are an electrical engineer, you have to have that 40 hours of training as a mandatory, and you have to show that 4 years of working experience if you have an associate degree, or if you have a bachelor's degree, then you have to show 2 years of verifiable work experience as a prerequisite of getting into the CSCP. If you are non-electrician, you are non-electrical engineer, but you are CSCP certified or safety professional, you are NEBOSH, you are ASP certified, you are CSCP certified, and you are a general safety professional, then you have to meet the requirement of table 1, yani 40 hours of electrical safety training, and you have to show that your work scope of safety includes interacting with electrical power systems. So once you have meet these requirements, you will launch your 40 hours of training and other table requirement as per your field. You will send your application to NFPA. They will accept. They will ask you to deposit 350 USD as an initial program. You will go for the exam. You will inshallah qualify, and after 3 years, you will pay $150 for recertification with proof of 50 credit hours as a continuous learning. If you fail the exam on the first try, you have to pay 300 USD as a retest fees. This is a chart I will going to share with you how you will claim your 50 points in future to keep your certification going every 3 years. These are my journey towards CSCP. I did approximately 11. These are some of the certification which I am showing right now. This is the 11, and I got 66.5 hours. The total requirement was 40, and I was, as a prerequisite, being electrical engineer with masters, I had 10 years of experience, and with the 66.5 as a prerequisite, they allow me to go for the CSCP. And CSCP exam is 180 hours exam with 100 questions, and I completed exam in 60 to 65 minutes because I've been teaching this topics since 2 and 3 years, the last 2 and 3 years, and for me it was good. It was not that tough. It was easy, and it's an open book exam. So who should go for the CSCP and CSW right now? If you are an electrical engineer, if you are an electrical manager, if you are a facility manager, if you are a maintenance manager, if you're a technician, supervisor, if you are safety leader, if you are risk manager, or if you are ASP and CSP certified and you want to add another title under your belt and want to have a more specific qualification domain of electrical safety, to have an electrical safety program going for your oil and gas field, your petrochemical industry, your general industry, your construction industry, and other. If you have an ISO 55 lead auditor with you, and if you want to explore, if as a freelance auditor or as an auditor, if you are going to some utility industries, to power generation, to distribution and transmission, so you need to have more information about their work. What are the hazards they are facing? So what could be the future career option for you if you are a CSCP certified combined with the lead auditor certification of ISO 45000 or lead implementer with some electrical safety audit? So you could be an electrical safety trainer, instructor. You could become an electrical safety auditor. You could become electrical safety consultant and implementer and this, and within the industry, you can develop your own best practices to make your complete system safe. What we are offering in this domain, we have made a number of courses to meet the target of 40 hours. First is the electrical safety for engineers and supervisors, which is planned from 1st May to 3rd May. It is a 10 hours course, and we will be presenting in evening hours during the month of Ramadan, 3 hours daily and 1 hour exam. Other courses are arc flash risk assessment, electrical safety program development, electrical safety audit compliance in NFPA 70 requirements, some introduction course. These will be as per the need and as per the requirement of our audience. But electrical safety for engineers and supervisors, it is based on NFPA 70E, and we will be initiating from 1st to 3rd May. The details will be shared with you by email and WhatsApp group. So here I'm ending my presentation. If you have any question regarding this topic, because it's a very long topic, and so I'm open to for any questions.
Thank you, Mr. Wasif, for the wonderful presentation. Let's move towards the Q&A session. For fresh electrical graduate and master, what will be the first step towards going through the certification? One of the participants asking.
Main thing is that minimum for the electrical engineers, you need 2 years of verifiable work experience and 40 hours of electrical safety training in last 3 years. So you can plan your safety trainings one at a time. Just when you meet your 2 years target and you have 40 hours ready, you can go for the CSP. And the exam is a computer-based exam, and it can be taken worldwide just by going to the person. You have to locate a testing center, go for the exam, give the best shot in your 3 hours, and be a certified CSP.
All right, thank you. Is electrical safety is a serious career development path? One of the participants asking.
Sorry, can you ask again, please?
Is electrical safety is a serious career path of an individual?
Just to show this, I've just taken one example of US. You can see the salary range of 67,000 to 100,000 plus. This is for the electrical safety coordinator. If you go into the details and if you search with the United States and other electrical plus safety or NFPA or CSCP certification, the things are changing. The organizations now need a competent person, and the CSCP is the only highest certification available, which can increase your salary range by 5 to 10% for the same work which you are doing.
Perfect. Anyone else who want to ask something directly to Mr. Wasif?
Mr. Wasif, I have just one question.
Yeah.
Regarding the course which you are saying that you are going to offer from 1st May to 4th May, I guess, could you please tell us the details about that course?
That is electrical safety for engineers and supervisors. In that course, we will be discussing in detail about what I just showed some examples about the arc flash hazard, what are the basic electrical hazards available, how to conduct the risk assessment of arc flash and arc flash. It's linked with the NFPA. It's totally based on NFPA 70E, and it is an accredited course from OSH Academy. It will earn you a 10 contact hours, which can be given for NFPA 70 CSP exam, towards CSP exam. Later, we have a target of conducting a full flash preparatory course for this one, in which we will be more discussing about the questions, type of questions and other things. So that will be a preparatory for CSP only. But this course is towards, if you want to have a general knowledge about the electrical hazard, it's fine for you. You can stop at that 10 hours. But if you are really serious about in achieving the CSP, then you will move towards the 40 hours. You can take trainings from other places as well in this journey.
For registration detail, Mr. Harun, you can feel free to contact with us at training@hseqprofessionals.net. Thank you.
Thank you very much.
Thank you all for your time, taking your time. I hope it has given you a bit information about knowledge about what are the career options available. In this competitive time, you should develop skills in more than one area to remain competitive, and always have an option of freelancing. And these type of certifications and qualifications will give you an edge of your competitors, and as well will open new ways for you. Once again, thank you.
Thank you very much.
If you have any question, just
Thank you very much, sir.
Thank you. Bye-bye.
Thank you.
Thank you, Mr. Wasif. Thank you all the participants for joining us in this webinar of Quality Management System 45,000 and electrical safety. Stay safe, stay healthy. Goodbye.